Eli, hello. Welcome to the show.
Hey, Jamie. Happy to be here.
To accelerate battery manufacturing, is data analytics the key? I'm joined today by Eli Leland, who is the CTO and co-founder of Voltaiq. I've heard a lot of hype recently around data analytics, whether that be in research and development or manufacturing. So it was great to hear from an industry veteran who's been in this space since 2012. Hear from Eli on how data analytics is currently contributing to battery manufacturing, how it could potentially be our solution as we look to achieve lofty battery manufacturing goals by 2030, as well as his outlook and prediction for how artificial intelligence will play its role in our industry. We hope you enjoy. Let's start off with your career to date. Talk us through your journey and how you joined Voltaiq.
Sure thing. My career started, I trained mechanical engineering as an undergraduate. Coming out of undergraduate, I worked in enterprise software, initially as a member of teams and later leading teams, doing enterprise software rollouts at large global companies. But after that, I was bitten by the energy bug. I had some experiences traveling and kind of seeing the impacts of climate change in real time. This is going back over 20 years, and was inspired to pursue a career related to energy and sustainable energy in particular. So that took me to University of California, Berkeley, where I did a PhD in mechanical engineering, again with a focus on energy science and technology, more specifically electrification, and took a very broad-based curriculum in energy, both from kind of the science and engineering aspect, as well as the policy and markets kind of aspect. So coming out of grad school, I had the opportunity to lead a team developing a new type of electric power converter for things like LED lights and mobile electronics, stuff like that. And I happened to be working in a lab that also had multiple different projects going on related to electrification. Another major project there was to develop and commercialize a new grid-scale battery chemistry, which based on, effectively alkaline materials, basically the kind of stuff that's inside an Energizer or Duracell battery. So I was leading a team developing this new type of electric power converter based largely around a new capacitor technology, and capacitor is another type of energy storage device. And my colleague sitting in the next cubicle was leading a team developing a new grid-scale battery chemistry. And so we were, it so happens that we had developed some internal software tools to help accelerate our data management and data visualization work. And they proved very instrumental in kind of accelerating our work. We got a lot of external validation just for these internal tools that we developed. We had a lot of people coming through to visit our lab and learn more about our technologies, our capacitors, and our batteries. And these were people like venture capitalists or, Department of Energy program managers who were seeing many, many other similar early stage development efforts around electrification and batteries. And the feedback we were getting was that the hardware technologies we were developing was interesting, but that we really had kind of our, little development group had a next level capability in terms of agility with data and analytics relative to all the other companies that they were seeing. We both, my eventual co-founder, a guy named Tal Schulklopper, who's now Voltaiq's CEO, and I, we were very entrepreneurially minded. We were interested in starting some company related to electrification and sustainable energy, thinking that it might be something related to batteries or, capacitors, power converters, stuff like that. But ultimately, we decided to start Voltaiq as a software company to bring enterprise software to the battery sector. And as far as what inspired us to come together and found Voltaiq, I think there were a couple different themes that ran together there. So one was, as I just mentioned, we were both working on electrification. Tal was working on batteries. I was working on capacitors. I was very interested in moving closer to batteries because I really saw it as this key enabling technology to the energy transition. And there were a couple things that were interesting about the battery sector at the time. Number one, it was already an enormous, we started the company in 2012 and over a decade ago. And at that time, the battery industry was already this huge, huge industry vertical that was already close to $100 billion industry globally, supporting many trillions of dollars in value. If you just think about the consumer electronics that at the time were all powered by batteries, that's trillions of dollars in annual economic value supported by batteries, and there was no software ecosystem whatsoever to support the battery industry. And that was in stark contrast to other similar high-tech verticals like semiconductors or pharmaceuticals, oil and gas, all of which have multi-billion-dollar software ecosystems just to support that industry vertical. So the battery industry had nothing. So we were, very interested in seeing how we could fill that void. That was one thing. A second thing was we were getting this validation for the tools that we had built basically to manage and visualize very large amounts of data coming out of batteries. And so we knew we had built some very basic tools that were providing value to people directly involved in doing battery engineering, and we thought that there might be an opportunity there. And then the third thing, and this really gets to kind of what Voltaiq's kind of reason for existence and our product vision is, it's really about empirical data analysis. And so the sort of background on this is that batteries as a technology are inherently they're highly kind of variable in their performance. We all have that experience of not knowing on any given day how long our cell phone battery is going to last. That's common across many different types of battery chemistries and battery applications. And it turns out that in many ways, batteries are these incredibly complex devices with all kinds of chemistry and physics going on inside them all the time. And even as you charge and discharge them repeatedly, they grow and they swell and shrink almost imperceptibly, like they're breathing. So in many ways, batteries are more like organisms than they are like other technologies like semiconductors or mechanical devices. And because of that really highly variable and unpredictable nature, they really lend themselves very well to being a big data problem. Really, the only way to properly engineer and operate a battery system is to build a lot of prototypes, do a lot of testing under all possible application scenarios, and look at the real empirical data that comes out of that work and see what it tells you. So those kind of three things came together, both recognizing that there was this opportunity to bring enterprise software to the battery sector, having this direct experience of having built some software tools ourselves that were data oriented, that were providing a lot of value to people working on batteries, namely us and our colleagues. And then the kind of inherent nature of batteries as these highly complex, almost organism-like devices and systems that we really wanted to bring enterprise software to the battery sector with that that empirical data analysis at the core of the product vision.
You mentioned interesting about mobile phone batteries. We had Samira from Innovix on the show, and we're talking about how AI is affecting battery life like crazy. So super, super interesting. Moving on, and the key secret I think that is on everyone's mind, of course, you incorporate the business in 2012, 12 years ago. Running a startup is difficult. How have you been able to maintain a full and thick head of hair during this time?
Genetics. I can't take any personal credit for it whatsoever.
It's impressive, and I'm very envious.
Although I will say, yeah, this beard was more like this color when I started this journey, and it's the white has definitely crept in, as my children remind me constantly.
Well, congratulations on that, first of all. I was fortunate enough to meet with Walid your colleague Walid in Stuttgart in Germany for the battery show. So he gave me a really good explanation about what Voltaiq is. But for our listeners, can you explain to us in simple terms what Voltaiq is, how it works, and where are your customers who are battery manufacturers seeing the most value?
Yeah, absolutely. So I'm gonna go back to that sort of analogy of batteries as living organisms, right? And so if you think about a battery, most of the batteries we work with and the companies, that are in manufacturing and developing battery products that we work with are some variation of, lithium-ion chemistry, rechargeable battery applications. And if you think about, and of course that's sort of, 90% of the That's the technology that is really transforming transportation, personal communications and information services, energy on the grid. It's all about basically rechargeable lithium-ion batteries of one sort or another. Now, if you think about one of those batteries as it's operating, as you charge and discharge it, its voltage goes up and down. And if you sort of record that data and chart it out, you can think about it as the battery's heartbeat. And in the very same way that, for a person, when we're interested in learning more about our own health, we can, a doctor can listen to our heartbeat with a stethoscope, or we can get an electrocardiogram, which shows the electrical pulsing of our heart. And, any layperson can look at that signal and see, oh yeah, there's a heart beating there. But a doctor can look at that signal and identify all kinds of different signs of, past health issues, future health issues, long-term, potential health risks, et cetera, just by looking at that signal of a heartbeat and identifying key signatures of all of these different things, good or bad health. So what our software does to first order is we look at that voltage and current heartbeat signal of every battery, and we're like an algorithmic cardiologist for the battery, where every single battery that's analyzed by Voltaiq, we look at that heartbeat signal, and we can extract a whole bunch of metrics that are indicative of good battery quality, bad battery quality, that can clue us into manufacturing quality issues, that can indicate how that battery is aging and degrading. And so to first order, that's what Voltaiq does. So we capture all of that data, and in a manufacturing context, which is where we're seeing a lot of our growth right now, we're working with companies that are manufacturing batteries. It so happens that this battery's first electrochemical heartbeat is generated at the very end of the manufacturing line. So battery manufacturing is this hugely complex process where you make slurries for your electrode materials, you coat them, you assemble the battery, you fill it with electrolyte, you seal it up, and then the final manufacturing step is actually to do some very carefully controlled charging and discharging to form the internal structures within that battery. And that process is called formation. And so formation cycling is where the battery's heart first beats. So we capture that battery's initial heartbeat on the manufacturing line and can again extract metrics that are indicative of good manufacturing quality or poor manufacturing quality or anomalous quality relative to all the other batteries that you've produced. You have some specification, some expectation of what you should see. And if you see any deviation from that, you want to look into your kind of upstream materials and process to understand why. So our software on the manufacturing line provides that very early quality signal, basically as soon as the battery is finished being assembled. Now, by contrast, the existing practice within the industry for final QA, quality analysis of all the batteries coming off a manufacturing line, is to perform that formation cycling, look at some very high-level metrics, but not look in depth and detail at that heartbeat signal the way our software does, and then to actually put that battery on a shelf and store it for 2 to 4 weeks, and then do some more measurements on it. And at the end of that 2 to 4 week aging process, you have a final assessment of if that battery meets the manufacturing quality standard or not. So the manufacturers are seeing value from our solution in that we can tell them if their batteries have a quality anomaly or not 2 to 4 weeks faster than using existing quality engineering practices. And now where that really adds up in terms of the economics of battery manufacturing is, especially as the industry is in this phase of massive and rapid growth, it turns out to be a very difficult and expensive endeavor to ramp up a battery factory from zero to full production. And what you end up doing is, it's an incredibly complex process. There are literally thousands of different, equipment and process set points that you have to dial in perfectly to get good batteries out of the end of your process. And so there's an iterative process of basically you kind of, you take your best assessment of what all those set points should be. You make some batteries, you assess their quality. Again, using this process, it takes 2 to 4 weeks after that final assembly to understand if the batteries are any good. And then you try and understand what are the upstream things that you can fix to improve battery quality. So what we can, and in aggregate, that process ends up taking even the largest global companies battery manufacturers that are very good at this, it still takes them up to 4 years and costs many billions of dollars to ramp up a factory to full production before it's running profitably. So what our solution helps to do is dramatically reduce those iteration cycles. We can give a quality signal much sooner in that iteration cycle, and we can correlate and identify potential root causes of the quality issue upstream. And what that adds up to is much faster iteration cycles and shorter ramp-up times with less scrap waste for battery manufacturers. And that's where the real economic value comes.
How receptive has the industry been to analytics? It's something that I've noticed a lot more of recently. You've been doing this since 2012. So how are you seeing the trends and what are the challenges that you see?
Indeed, it's a great question. So, it's really been a journey. As I mentioned, we founded the company 12 years ago, and we've seen just a dramatic transformation, kind of industry attitudes toward battery analytics generally, and the value in industrial applications. I think it's useful to sort of look at the sort of development trajectory of other industrial software technologies. If you look at something like, simulation software, right now at present there's a gigantic multi-billion dollar industry around simulation software for engineering of all kinds of different applications. But if you rewind the clock a couple of decades, there were no, commercial vendors for that type of technology. And what you had was large companies employing teams of software engineers and PhD scientists to kind of create their own internal software tools. And then eventually, the use cases become kind of more generalized and better understood, and commercial companies arise. So we've really seen a lot of that journey take place just over the last 12 years since we started the company, where initially, we'd go to battery conferences and say, hey, we're a software company doing data analytics for batteries, and we'd get a lot of blank stares. And then, over the last several years, we've seen this evolution to where folks understand that software technology and analytics can be a solution to a lot of the challenges that they're encountering during the battery engineering and production life cycle, and have started coming to us with some more of that. But we're really seeing the industry start to turn a corner. And more in the last couple of years, we're seeing where it's understood that analytics are a core competency for any company doing really anything across the battery life cycle, because of the inherent nature of batteries as this kind of big data problem. There's awareness that there is now a burgeoning commercial software ecosystem to support it. And what we're seeing on the organizational side with customers is that the IT organizations are really starting to lead the procurement processes, because they're seeing different stakeholders within their organizations that need access to, to battery analytics or the output of that analytics, or, different stakeholders, suppliers, different groups, whether it's the R&D group, the quality group, the production group, that all kind of need access to a similar set of data and analytics. And so we're seeing a more of an IT-led procurement process. And I think, historically and still today, I would say that the number one alternative to going with an established solution like ours is to build some software internally using kind of those legacy practices of the more kind of immature software sectors. But what we're starting to see is there's studies that are showing what the real ROI is on going with like an established commercial product relative to starting from scratch and recruiting a team and building your own software. And that, it's that the ROI is, something like 6 or 7 times greater for just going with an established commercial product that can start adding value right away, versus going along that timeline that it takes to spin up your own internal efforts. And, a concept that we've been talking about lately as regards this is like, if you think about when you start a home improvement project, what is the first thing you do? You first make sure you have all the right tools that you need to do that project. And if you don't have the right tools, you go to the hardware store and you buy the right tools. What you don't do is start by forging your own hammer in order to, do a home improvement project. So, in our view, now that there is much more of a mature software ecosystem around the battery sector, that it makes a lot more sense, and the ROI studies are bearing this out, to go with an established commercial product rather than starting by forging your own hammer.
There's been obviously the big buzzword at the moment is gigafactories, and there's obviously so much investment across North America, and there's going to be more in Europe as well. Obviously, Asia is very well established. From the previous 12 years, how do you see the next 12 years changing? Do you see a faster acceleration when it comes to adoption of data analytics, and what do you see as the main challenges ahead when it comes to battery manufacturing across North America and Europe?
Yes, indeed. First of all, it's a really exciting time to be in this industry. Something that we joke about internally is that we've been waiting over a decade to have perfect timing for our solution, and so it feels like that's arrived, right? This notwithstanding some of the gyrating hype cycle globally around batteries and electrification, we're seeing a strong trend of growth, and especially growth in battery production, and lots of these gigafactories in various stages of development, as you talked about, across Europe and North America and Asia. So, first of all, it's just this really exciting time, and there's a lot of companies out there, both kind of as we talked about, the established incumbent battery manufacturers still have challenges ramping up their gigafactories, and then the new entrants that are associated, like OEM joint ventures or what have you, they're going to be learning firsthand what those challenges are. So when you ask about what we see, say, in the next 12 years and what are going to be the major challenges, I think there's a number of challenges that we see coming for the industry. So, number one is that there is a major dearth of human talent to support all of this growth. So we're looking at various projections. We would say that, let's say, roughly by the end of the decade, that global battery production capacity is going to grow something like tenfold, right? So that means 10 times as many factories, and you need 10 times as many people to run them. And so those people currently don't exist. They haven't been trained. And so, one thing that we hear from our customers that our software helps them do is actually recruit talent from other industries, because, without Voltaiq, the alternative is actually mostly companies working in spreadsheets to try and extract the kind of metrics and analysis. And in order to know how to process that heartbeat data and extract the metrics, you really need, a team of like PhD battery scientists and engineers like we have assembled internally that have guided us in development of our software. And so, we actually build all that expertise in, which enables companies that are using our software to recruit, manufacturing quality experts who can apply their expertise to this new domain, because a lot of the expertise around what you actually need to look for in those data signals comes out of our software. I think another major challenge for the battery sector, it's really just continuous and constant change. So, notwithstanding the fact that lithium ion is dominant, there are a host of technology trends, whether you're talking about silicon anodes to increase capacity, whether you're talking about lithium metal batteries, solid state batteries, or even just the incremental tweaks that are improving the sort of dominant battery chemistry performance by a couple % every year. All of those things are just driving the need to be on a constant learning cycle for all these companies. There's no such thing as like getting to the point where you've kind of mastered everything and you can set it and forget it and let your factory run for the next 20 years. Those chemistries, the technologies, and even the manufacturing technologies are going to be evolving. So companies really need to develop this kind of muscle memory around just constant iteration and constant learning. And again, that's something that's very at the very heart of the value proposition that our software brings is institutionalizing, democratizing, and ultimately accelerating those learning cycles around the battery sector. I'd say other challenges include kind of the same way that there's a lack of talent. There's also there remains an immature supply base of all the manufacturing equipment that is going to be needed to fill all these gigafactories and produce all of these batteries. So what we see right now is companies really scrambling, going around the world, largely to Asia, to look for the companies that can produce this equipment, and it hasn't been consolidated in terms of like major global suppliers the same way that there are in say the semiconductor industry. In the battery industry, it's really a lot of like mom and pop operations, relatively speaking, that are making this equipment. And so I think where that all comes together is you're going to have, a new cohort of people running these factories, new technologies, both in terms of the battery chemistries and the manufacturing technologies, and a highly heterogeneous set of equipment and technologies that are used to make these batteries. And you need to make it work. You need to be able to, get that plant up and running and constantly learn and improve. And so I think what's going to be vital is the maturation of the digital infrastructure within a gigafactory in order to provide that kind of connective information backbone that makes it all work together. And so, what I predict that will look like, and right now, by and large, as this is still a relatively immature industry, a lot of these systems are very siloed. So you have a whole bunch of different types of equipment that are operating on the production line. Each one has their own way of communicating and data standards. So there's opportunities for large integrators to come in and put the PLCs, programmable logic controllers, and all that equipment that make it talk to some centralized software system like an MES, a manufacturing execution system. There's a lot of work to be done to kind of standardize and get all of that equipment talking to each other. And then crucially, leveraging, battery analytics technologies to understand the quality of those batteries that are coming off your production line, and then marry that to all of that process and materials information that are kind of the inputs. So the materials and process are the inputs to making batteries, and those electrochemical quality metrics at the end of line are kind of your outputs. You can think about it in an information sense. And so what we're looking to do with our partners, and we're, as this ecosystem develops, we're partnering with leading companies like Siemens on the industrial automation side and AWS on the cloud infrastructure side to really bring all of these data sources together, apply the right type of battery-specific expert analytics to them to again, very rapidly give these companies a quality assessment and a framework for doing correlation root cause to quickly determine where the quality issues are coming from and how to improve them. So yes, it's going to be really exciting to see how things develop. But those I think are the major trends that we foresee.
Super interesting, and yeah, I think the talent issue and the staffing issue is prevalent because, yeah, as you say, we're going to be manufacturing batteries tenfold, I think particularly in the US, and where's all the talent going to come from? If it's going to be, dry process, we've maybe got more of a chance because there's more available talent in the US coming from other industries like pharma or anything to do with powder handling. Wet coating, maybe not as much, but even then, there's only still a certain amount of people on planet Earth, and then also a lot of our clients are, keen to bring talent across from China and Korea and Japan sometimes. And it's like, well, there's only a certain amount of those people who can come across as well. So I think, yeah, kind of leveraging technology is key to produce more batteries to, essentially whatever chemistry we end up kind of landing on next, or whether we just kind of make more of the same.
Yeah, it's really exciting to see kind of the global community that is forming around this effort. I mean, when we go in, when you go into one of these factories, you'll see people from, all corners of the world, joining forces to work to bring this up. A lot of it is, equipment suppliers that are based in various different places around the globe that are sending their teams, to actually get things up and running at these factories. But it's an exciting time to be a part of this effort.
Definitely. And we mentioned AI before. With that's now kind of coming into this era now, and something that I guess you'll be seeing. Where do you see what's your perspective of AI in the battery industry? So we talked before about actually AI is killing battery life in mobile phones, but in terms of actually manufacturing batteries, where do you see AI playing a big part?
There's clearly a lot of potential and a lot of excitement, and we have seen certainly since Chat GPT entered the public consciousness, there's really been a transformation in kind of people's aspirations and expectations for AI to transform everything, including batteries. I think, just to what we are actually seeing on the ground at companies is there's a lot of excitement around the potential for AI, but in terms of actual impact today in production environments for battery manufacturers, there's actually very little that's going on in practice today. It's really kind of more in the ideation phase. I will say that we saw. I'm optimistic about the potential for AI, but we did see a similar hype cycle several years ago when blockchain was sort of came to prominence within the public consciousness, and all kinds of companies within the battery sector and the sort of early battery analytics sector were starting to talk about things they could do with the blockchain. And here we are several years later, and all of that has kind of disappeared. I don't predict that the same is going to happen for AI. I think that there really will be real applications, but we're really not seeing it have a lot of an impact right now in manufacturing. And so what we have seen in terms of any kind of output results are generally in the form of kind of proof of concept or demonstrations about the potential for AI to do things in terms of, image recognition, processing, looking for, visual identification of defects and things like that, which, you could call that AI. You could also just call it machine learning, which is what people have been calling it for, the last decade or so. And in practice, we're seeing what a lot of people call AI really comes down to just basic statistical correlations that's being marketed as AI. So with all of that said, we believe that there is tremendous potential for AI in battery manufacturing, both looking at kind of the electrochemical heartbeat stuff and the various different manufacturing process and predictive quality applications on the manufacturing line, et cetera. What I will say is that in order to enable any of those efforts in a real production environment at enterprise scale, in order to enable AI for batteries, what you would need to start with is a data automation platform that is scalable to run to like full production scale, that can automatically capture all the data coming off of your production line, that can clean that data, that can link data from individual battery cells to its upstream processing parameters, et cetera, and then extract the metrics and to use the data science language, the data features that you then feed into ML and AI models. So in effect, what you would need to do in order to enable some, industrial scale, real production AI initiative is you would need to start by building a platform very much like Voltaiq. So in that regard, we often actually get asked if we are an AI company, which we are not. It's actually just coincidence that there's AI in our name. We didn't even think about that, honestly, until a couple of years ago when everyone started talking about AI. But what we are is a platform that can enable AI. And so when I go back to the earlier question about the industry's receptivity to battery analytics and how we're seeing this transformation from a tendency to build internally to a tendency to buy. To buy an established commercial product. In terms of supporting machine learning and AI efforts in the battery industry, our software is really an accelerator to those efforts. So, these companies that are recruiting, teams of data scientists and machine learning experts, they're really excited to find the models that are going to work for their specific application. And they're probably less excited about building up all the data automation pipelines that get all the data into the right place and right format to support that. So what we offer is a way to accelerate past all that so that, your data scientists and AI experts can really get right to the meat of the challenge. And I'll just say one more thing about our approach to AI is, I'd say that we've seen some skepticism in the industrial community and the community of large companies in the battery sector around taking what we'll call like a black box AI model. And this is kind of a bigger issue in the development of these really large and powerful AI models is explainability, right? Can you have this model that makes a certain prediction that can be uncanny, but can you explain why the model made it? In many cases, the development in AI is at a place where you really can't. You don't know why the model's making these uncannily, seemingly accurate predictions. And, what we see is that gives a lot of these larger companies pause, kind of trusting a billion-dollar battery product launch to an algorithm that they ultimately can't see inside of and don't understand. And so what we advocate for these companies to do is look, there's a large and vibrant open source community and a lot of battery modeling techniques in the academic literature and elsewhere, where what we encourage companies to do is sort of survey all of that and find the models that seem best suited to their application. We at Voltaiq, we have a battery engineering team that can engage with customers and help them do this. Once you find a model that you think works pretty well for your application, then you can take that in-house and we can help our customers basically adapt it to run in our platform and compare to all the empirical data. And then build your own IP on top of that model once you've kind of brought it in-house. And then you have a fully transparent model that you understand you've built your own IP on. And that's something that can give a lot more confidence around using that technology as part of a battery product initiative.
I'd love to do another episode in a year or two and just talk specifically about AI. I guess at that point, maybe you've rebranded and you put a circle around the AI or an underline. Yeah, let's maybe book that in. But really enjoyed this conversation, Eli. Thank you very much. To finish, I've got a question from a former guest. I've got a list here, and I'm actually going to pick out the one that mentions AI. And this former guest has asked, does AI, when it comes to battery manufacturing, excite you or scare you?
Oh, it definitely excites me. Yeah, it excites me to the extent that it scares me. I would just the only thing that's scary about it is folks that are out there marketing AI technologies that are not fully mature or explainable in the way that we were just talking about, and to the extent that those ideas, concepts, technologies gain traction before they're actually ready for prime time. I think that they could, if things don't go well, they could kind of set the rest of us back a bit. But in terms of the actual potential of these technologies, I absolutely think that they'll be transformative, whether they're true, AI in the, LLM sense of ChatGPT and these other large models, or if they're really just more applications of machine learning techniques that have been around for a couple decades, just applied at greater scale with enabling technology like, battery analytic systems and things like that. But definitely much more excited with just that hint of caution for the companies that are assessing these technologies to really have some confidence around the maturity and explainability and understandability of the results of these AI technologies as they're applied.
Well, me too. And AI is not going anywhere. It's here to stay and it's only going to grow. So we need to embrace it. Eli, thank you very much. I've learned a lot today on battery analytics. It's actually the first time we've had someone like you on the show. So thank you for sharing your insights. And I look forward to part 2 whenever that is, in a year or two. But thank you very much.
Thanks, Jamie. It's been a pleasure, and I will look forward to that as well.